right? So consider the partial schedule 9, right? So this is the partial schedule 9 in which a transaction T7 performs only one instruction, read operation on data item capital A. So we call this partial schedule because we have not included a commit or abort operation for transaction T6, right? So no commit or abort operation is included for transaction T6. Notice that T7 commits immediately after executing the read of a instruction, right? So T7, the transaction T7 commits while T6 is still in the active state, right? So you have two transactions, T6 and T7. T7 has only one instruction which reads the value of data item capital A that is being read by transaction T6. So once it reads the value of data item, it commits, whereas transaction T6 is going to be still in the active state. Now suppose that transaction T6 fails before it commits. Transaction T7 has read the value of a data item written by transaction T6. Therefore, we say that T7 is dependent on T6. Because of this, we must abort T7 to ensure atomicity property. However, T7 has already committed and cannot be aborted, right? So we have a situation where it is impossible to recover correctly from the failure of T6, right? So this is known as non-recoverable schedule. So how to make it a recoverable schedule? To make it a recoverable schedule, whenever a transaction, you have transactions TI and TJ, such that TJ reads the value of data item that is written by TI, then the commit operation of TI should occur only after the commit operation of EI, right? So that's known as recoverable schedule property, right? So you can look into the recoverable schedule property. Right. So a recoverable schedule property states that for a pair of transactions TI and TJ that are executing concurrently, and TJ reads a value of a data item that is being previously written by TI, the commit operation of TI should appear before the commit operation of TJ. Then it's possible to make it as a recoverable schedule, right? So for example, in the schedule 9 to be recoverable, T7 should have to delay its commit operation until T6 commits, right? So you have a pair of transactions TA and TJ, T6 and T7, such that the transaction TJ reads the value of data item capital A that is being written by transaction T6. Then the commit operation of T7 should occur only after the commit operation of T6, right? So we have to delay the commit operation of T7 till the transaction T6 commits. It's known as a recoverable schedule. Whereas this is an example of non-recoverable schedule, right? So in this case, let us assume that if the transaction T6 fails over a period of time, what happens is like T7 has read a value of data item capital A that is being written by transaction T6 and it has committed. Whereas over a period of time, the transaction T6 cannot proceed and it has to be aborted. So we have an inconsistent state, right? So, and it is possible to abort only the transaction T6. It is not possible to abort the transaction T7, which is dependent on transaction T6. Hence, it's known as non-recoverable schedule, right? So, hope you can understand the difference between a recoverable schedule and non-recoverable schedule. So whenever you have concurrent transactions, we need to commit things in such a way that you have this, it satisfies the recoverable schedule property, right? So for a pair of transactions, TA and TJ, that are being executing concurrently, such that TJ reads the value of data item that is being written by transaction TI, then the commit operation of TJ should occur only after the commit operation of TI occurred. It is known as recoverable schedule. So in the previous example, we can make the schedule recoverable by delaying the commit operation of transaction T7 until T6 commits.